Good morning everyone. Today we will start with a new topic which is data frames in Python. Before learning about data frames, we are going to have a look on different structures. First we can see over here that it is a point, and we all know that a point is a zero-dimensional structure. Next one, we are having a line which is a one-dimensional structure because it is always growing in only a single direction. After that, we are having a shape like a square, which is a 2D structure, or you can say it's a plane. Next, we are having a solid, which is a 3D structure, just like a cube. Same case, we can take the other examples also. Here you are seeing a line over here, which is a one-dimensional, a square, circle, triangle, which are the 2 dimensionals, and the cuboid and the cylinder form, which are the 3-dimensional structure. Even in our daily life, we are having a real life example which we are seeing nowadays frequently, which is a barcode reader. Yes, a barcode reader can also be a 1D and a 2D structure. The line one, which we are seeing on the products or we are seeing on the text, it is in the one-dimensional structure, whereas the barcode which we are using for the payment and the other things, it is a 2-dimensional structure. Why we are studying about these structures first? Because in this chapter, in this topic, we are going to focus on a 2D structure, or you can say a 2-dimensional structure. Now let us have a look at a graph. A graph is having a 2 axis, or you can say it's a 2-dimension. One is a x-axis and the other one is y-axis. While writing a coordinate, for suppose this is a coordinate over here, right? So if I want to write the coordinates here, then it is 2, 5. Why it is 2, 5? Why we are writing 2 instead of 5 first? Because first we are taking x-axis, then we are taking the y-axis. First we are taking row or the horizontal one, next we are taking the vertical or the column one. Okay, so let's move to our topic, which is data frame. What is a data frame? A data frame is a 2-dimensional, because I already told that we are focusing on 2-dimensional structure. In this chapter earlier, we learned about the 1-dimensional structure in the Pandas library, which is known as series. Now we are having the 2-dimensional structure, which is known as data frame. And if we are saying that it is a 2-dimensional structure, that means we are having 2 axes over here. Okay, one is x-axis and the other one is y-axis, right? Instead of saying it as x or y-axis, we are having axis 0, which is a row 1, and axis 1, which is a column 1. Okay, we are having the column names as name, team, number, which are representing with the blue color or the blue mark. After that, we are having purple color. In purple color, we are having index labels or the row labels, which are axis 0. Okay, next you can say that see that here with the pink line we are having NaN noted things. Why it is a NaN, or what is the full form of NaN? NaN is not a number. Why we are having not a number over here? It represents the missing value in a table or in a data frame. Then and we all know that Pandas is having a property of handling missing data. That is a NaN, not a number. Next one we are seeing here, like we are having the data in the case of float, integers, and string or objects. So we are having different types of data, due to which it is heterogeneous data type. Now I think we are able to form the definition of data frame, that it is a 2-dimensional structure. Size mutable, I will tell you later on what is a size mutable means. It is a heterogeneous tabular structure. Why it is a heterogeneous tabular structure? Because we are having different data types. Next one, what is a data structure? Data structure means how we are able to store data in our memory or in our language with the labeled axis. Why we are having a labeled axis over here? Labeled axis means that we are having axis 0, we are labeling it with 0 to 6 over here, and column names on axis 1, which are name, team, these are the label names. Okay, so labeling them is a labeled axis, and we are storing the data in the form of a tabular fashion, in the form of row and columns. Now I think your definition of data frame is pretty much clear to you. Now we are moving towards the characteristics of a data frame. Characteristics of a data frame, as we all know that it has 2 indexes. Okay, a row index, which is at axis 0, and the other one is column index. Here I think we are able to identify which is a row index and which is a column index. Yes, 0 to 4 is our row index or the index labels. Okay, and over here rank, discipline, these all are the column names or the column indexes at axis 1. This is the axis 1. The vertical one is always axis 1 and the horizontal one is always axis 0. Next one, like a spreadsheet, or you can say it like Excel, where indexes can be number, letters or string. Same case in data frames, it is not compulsory that we are having always indexes in the form of numbers only. It can be A, it can be B, it can be C, or it can be a name of any person, right? We can also write here Sita. It is also acceptable in the form of data frame. Now columns can have a different data type. That means it's a heterogeneous data type of a structure that we have learned earlier. Now the thing arises, what is value mutable and what is size mutable? Value mutable means if I created a data frame, then I'm able to change the value in the data frame after creating it. Because of this, it becomes the value mutable, and it is the main difference between a series and a data frame. Next, the same case which also proves the difference between a series and a data frame, that it is a size mutable. Size mutable means I can increase or decrease the size of the data frame after creating it. So now we are moving towards our next topic, creation of data frames. We are having many methods to create a data frame, but in our syllabus we are focusing on basically 5 methods. From those 5 methods, I am explaining 4 to you over here. First one is dictionary. As we all know that dictionary is the built-in data type in Python, which is in the notation of key and value. As we all know that dictionary is a key value pair. Okay, so I'm creating a dictionary over here. First, I'm giving the name to the object of dictionary, that is dict1. Here I'm having keys students, marks and score. Next thing, I'm taking values as list or ndarray. Ndarray means n-dimensional array, and array is a homogeneous type of element. That means it is having a collection of same data types. Here I'm taking the values as a list. Okay, I'm taking the student's name, their marks and their sports. Next one, I'm printing this dictionary by using the print command. After that, I'm creating a data frame object which is df1. I'm using a library Pandas because we all know that data frame and series are the function of the data structure of Pandas library. Why I'm writing PD over here? Because earlier I've used import function or the import command to import the Pandas library, which is import Pandas as PD. So PD is used as a nomenclature for Pandas. I'm writing over here PD dot data frame. Data frame is a function, and you have to keep this thing in your mind that D and F of data frame is always capital, else it will give you an error. Okay, now I'm passing this dictionary object to this data frame function. After that, I'm printing this data frame. So while this command, print command, I got the dictionary in the form like this. And as we all know that data frame is a 2-dimensional structure, so after printing data frame, I get the output like this. Here 0, 1, 2, 3 are the row indexes, or you can say the index labels at axis 0, and students, marks and sports are the column names, or you can say that these are the axis 1. Why it is 0, 1, 2, 3? Because I haven't specified any index over here. That's why by default it is 0, 1, 2, 3. Why it is by default 0, 1, 2, 3? Because we all know that Pandas is based on which package? NumPy package, and NumPy is made up of array, right? So that's why its initial indexing is always 0, 1, 2 and 3. Now we are moving towards the next method, which is having values as a dictionary object. Here I am creating 3 dictionary, year 16, year 15, year 16 and year 17. In this I am taking keys as Q1. That means it is showing the sales of a company in 3 years over 4 quarters. Next Q2, next Q3, 3 in third quarter and same in the fourth quarter. In every dictionary I have marked the 4 quarters. After that I'm creating another dictionary, sales, where I'm passing all the 3 dictionaries to that new dictionary with the key value pairs. Right, I'm giving the key as 2015, 16 and 17. Children, keep this thing in your mind while you're creating values as a dictionary objects. Then please keep the index values same in all the dictionary, else it will gives you NaN or error. After that I'm passing this sales to this data frame object that I'm creating df2 sales over here, and I'm printing that df2. Now in df2 I got the q1, q2, q3 and q4 as your row labels. See, I told you that we can take any string or letters or numbers in index labels. Okay, next we are having the keys from the dictionary 2015, 16 and 17. So it's another way by using the dictionary to create a data frame. Next one I'm having from 2D ndarray. As we all know that ndarray is n-dimensional array. Okay, and I'm using 2D. How we are recognizing that it's a 2D? First thing, I'm creating an object of ndarray, that is NA. Next, I told you that Pandas is based on the NumPy package and array function belongs to the NumPy package. For this, I'm importing the NumPy library, that is import NumPy as NP, and array function is from this. Now, if we are having square bracket at the end of the start of the list, then it means it's a 2-dimensional array, and I'm taking the data type as int32. In32 all the data types also belongs to the NumPy package. After that I'm creating a data frame object df3, and same I'm passing this ndarray object to data frame NA. After this I'm printing the data frame. Here I'm getting the result as 0, 1 because I haven't specified an index or the column names over here. That's why on axis 0 I'm having index labels as 0 and 1, and next I'm having column names which are having the column names as 0, 1 and 2. Now I'm giving you the next example. If I'm writing columns and index name over here, then what will happen? See children, I'm using column names as FST over here because we are having 3 columns over here. Okay, next I'm giving index name as A and B because it's 2 rows. One is this one and the other one is this one. Okay, this is row 0 and this is row 1, and same case it is column number 0, 1 and 2. So here we are having the columns name as FST and the index name as A and B. So till now we have learned about to create a data frame by 2 methods. One is from dictionary, in which having values as list or ndarray. Next, having values as dictionary objects. Next, from 2D or ndarray. Now I'm moving towards our third type, which is from 2D dictionary using series. As we all know that series is a 1D data structure in Pandas, and on series we can apply arithmetic operations. So here I'm creating a first series object that is named as POPU. Okay, because series belongs to Pandas, so here we are using PD dot series. Since similarly like data frame, we are also having S of series as capital, and I'm giving the index values as I, B, C and P. After that I'm creating another series object AC, and similarly I'm creating the series value over here. Please keep this thing in your mind, the index should be same in both the series object. After that, since we can apply arithmetic operation to series objects, here I'm creating another series object that is rate, and I'm dividing POPU by AC. Okay, so this will automatically becomes a series object also. After this I'm creating a dictionary. Till now I have created the series, right? I told you that I'm creating to data frame from 2D dictionary using series. That means I'm passing series object to dictionary. Till now I have created 3 series object. Now I'm creating DICT2 as my dictionary object, and I'm passing these series object to my dictionary as value POPU, AC, and next one is rate, and I'm giving the keys as population, which will become the column's name, average income, and per capita. Now after that I'm creating the df5 that was my data frame object pd.dataframe. I'm passing the dictionary object to my data frame. After that I'm writing columns. Keep this thing in your mind that the keys in the dictionary should be same as the column name in the data frame, else it will give you an error. Okay, I'm telling you that keys should be equal to column names in your data frame object. Okay, now after printing the output, I'm getting output like this: IBCP, which was the index given in the series object earlier. After that, population, average income, per capita, which were the column names and the key values given in the dictionary and the data frame object. Okay, now moving on towards the next one, which is from another data frame object. It's a very simple one. Since we have created a df3, that is the data frame from 2D ndarray, okay, in which we have given the column names as fst and row labels as a and b. I'm just passing that data frame object to the data frame method. I'm printing that another data frame object df6. So children, till now we have learned about the 4 methods. One is from dictionary, which is having values as list, or ndarray, which is having values as dictionary object. Second method is from 2D ndarray. Next one is from 2D dictionary using series, and other one is from data frame object. There is also one more method, which is a CSV file, comma separated value, which I will describe it to you later on. So till now you have to focus on these 4 methods.